Okay, kiddos. So this is for my honors geometry class. And what I'm doing here is, first things first, I want to run through some of the notes because I know there's some people out there who didn't get a chance to take notes today because they were gone. So what I'm going to do is I'm going to quick run through them. So this is the hierarchy of quadrilaterals. Just want to see how they all fit together. And basically, the rule is that the properties of things work this way. So if I'm down here at a square, I have all of these properties above me, okay? So it does not work this way. So just all trapezoids are quadrilaterals, not all quadrilaterals are trapezoids. So moving on. Properties of a rhombus, or rhombi if it's plural. All the properties of a parallelogram, plus it's equilateral. All four sides are the same. It has perpendicular diagonals, and diagonals bisect in the opposite angles. So I'm going to go through this probably faster than you're going to write it. So feel free to hit pause, copy it down if you don't have it already. Squares have all the properties of parallelograms, all the properties of rectangles, and all the properties of rhombuses, or rhombi. They don't have any individual properties, so there's nothing that is just a square. A square is a combination of all of these three. So trapezoids, parallelograms with only one set of parallel lines. Okay, so let's go to these two. So we have non-isosceles trapezoids. It says one set of parallel sides. Those are called the bases. On that diagram, it would be A, B, and DC. And then consecutive angles, so like angle A and angle D, would be supplementary. And that's just parallel lines with the transversal, so those are just same side interior angles. We then have isosceles trapezoids. Why isosceles trapezoids? Well, because the legs are the same length. You can see that right here. Congruent diagonals, and the base angles are, so D and C are congruent, A and B are congruent. And then because we still have the fact that these sets A and D and B and C are still supplementary, we know that A and C are supplementary, as are B and C, or B and D rather. B and C are also supplementary. So let us start pulling in the worksheets. Just going to do a couple on each one. Okay, so here are the rhombuses and squares. So here comes London, so I'm going to hit pause. And we're back. So I already did number 1 in class, so I'm going to do number 2. And I'm going to hit the right button. So, woohoo. Okay, so these are all rhombuses. How do we know? Or rhombi, because it says so. So we know that BC is 28. Now, because we know that BC is 28, we automatically know that all of these are 28. So what I'm going to do here is I'm actually going to fill in all of the lengths and then figure out what goes where over here. We also know that B to D, so that's this whole thing right here, is 32. Okay, which we also know that because it's a parallelogram, the diagonals bisect each other. So half of 32 is 16. Because this is a rhombus, we know that all of these are right triangles. And so lo and behold, we can actually figure out, so this is going to be EF down here on the bottom. I basically pulled out this triangle right here. So this is B up here. And notice that this is 16 and this is 28. So what we can do is we can go that EF, the distance from E to F, equals the square root of 28 squared minus 16 squared. And so we just plug that into our calculator. And we get 22.97. So that's going to round up to 23.0. 23.0, which would make the whole thing 46. So CD, that's a side, 28. F to D, that's 16. That's half of the B to D diagonal they gave us. E to F, we figured that out. That's 23.0. And E to C, that's that full thing. So that's 46.0. Easy peasy. Here, I'm going to just really quick on PQ, I'm actually going to go back to number 3, and do the angles. I'm not actually going to do the other part because we already did the sides. But here, we have two sides that are just listed like that. And we're being asked to find this side. Well, because it's a rhombus, we know all the sides are the same. So we just set 5x plus 16 equal to 9x minus 32. 4x, 48, x is 12, 60, 72 would be your answer. Okay? Do the math, but it should be 72. If I'm wrong, which I could be because I just did that really quickly. Anyway. So here, we have MJL is 50 degrees. Okay, so MJL right here is 50 degrees. Now, what we're going to do is we're going to say, we're going to figure out everything else. Okay? So we know that this right here is 90. So all of these middle ones are 90. And because all three of these right here have to add up to 180, we know that JMN is going to be 90 plus 50 is 140, so this is going to be 40. We have also been told that because it's a rhombus, the diagonals bisect each of the angles. So now we can just go around and going 50, 50, 40, 40. Because it is a parallelogram, we know that opposite angles are congruent. So that means over here is going to be 40, 40, 50, 50. And then you would fill in over here. We would go K and L is 90. KJL is 50. MLK is what we celebrate on Martin Luther King Day. That'd be 100. JKM is 40. And JML is 80. Okay? On the back side, I'm just going to kind of scroll through. But basically, you have from 9 on, so 9, 10, 11 through here, 9, 10, 11, 12, they're squares. So really all you have is the same properties of a rhombus with its properties of a rectangle. If you're not sure what those are, head back to my other video. So I'm going to skip ahead to trapezoids now. And we're going to look through some of these. So each quadrilateral is a trapezoid. Okay. So notice that on 1, 2, 3, 4, 5, 6, 7, 8, or all the way down to 6, they're just regular trapezoids. They're non-isosceles. 7, see how they identify that the legs are the same? 7, 8, 9, 10 is isosceles. 11 won't be. 12 won't necessarily be. But yeah, so, okay. So let's go through just a couple of these, and I might just kind of talk through them. So here we know that these two angles have to be supplementary. So you're going to go 180 minus 79 to get C. and you're going to go 180 minus 134 to get E. So that's how all of these top ones are going to go. Now here on 3 and 4 are isosceles. Silly me. Okay, so number 3's isosceles. So not only do we know that these two angles are supplementary, but we know that these two angles and these two angles, these base angles, are congruent. So if K is 83, we know J is 83. And then we would know that both of the other ones have to be 97, because that's how we get K and L and then J and M to be supplementary. And also, these two need to be supplementary as well. Okay, 5, 6, 7. We would use the same process, except you're going to have to do an equation. 7, because those are two base angles, you'd set them equal to each other. 8, because it's these consecutive angles between, you'd add them. 13x minus 7 plus 8x minus 2 equals 180. Here, 9, because it's an isosceles triangle, we know that opposite angles are congruent. Here, you're going to play a little bit on what the diagonals do and how the diagonals work, and that they're congruent. So this is the midpoint, so we didn't really go over this, and that's okay. We know that this right here is the average of the two bases. So that's going to be 27 plus 39 divided by 2, which would be 66 divided by 2. So this right here is going to be 33. Which then also means that if we're looking for AB here, we know that 29 plus x divided by 2 equals 22. So 29 plus x equals 44, or x equals 15. You do the same thing for 13, except I'll set it up for you, but I'm not actually going to solve it. Add the top and the bottom, divide by 2, get that. So you would solve that for x, is how you do it. Okay? And that is all the fun we've had with trapezoids. So let's move on to kites. So we already did that one. So all these are kites, meaning that they have two sets of consecutive angles. So like here, we know that one set of the angles, if you go back to what your kites said, you know that one set of the angles is congruent, and that's going to be these two right here. It's where the two consecutive sets of congruent sides touch. So if that's 65 across the way, this is 65. And then V, we know that all three of these have to add up to 360 because it is a it is a quadrilateral. We know that the interior angles of a quadrilateral have to add up to 360. So we go 360 minus 91 plus 65 plus 65. So we have 360 minus 139. So that's 139 down here. Let's look really quickly at number 4. So number 4, zoom in down here. So I'm just going to draw it on the actual diagram. So we know that A to B to C is 70 degrees. So we know this is 70 degrees right here. And we know that A to D to C, this is down at the bottom here, is 46 degrees. Well, what do? Well, we know that A and C right here, we know that they are congruent. So let's call them X, okay? So we know that 70 plus 46 plus 2x equals 360. Okay? So we know that 116 plus 2x equals 360, or 2x equals 244, or x equals 122. So that's angle A and angle C equal 122. Okay, now we know that, so we know that 5 and 7, 1 and 6 have to add up to 122. So when we start labeling them, we know 4 is going to be 90. Okay, so I'm going to erase this right here just because we've already done that. We know 4 is going to be 90 degrees. And so let's just focus on that triangle, 3, 5, and 7. Because of side congruency, or rather side congruency, because we know that these two are the same. We know that these two are the same. And we know that B to D is the same. So we have side congruency between that big left triangle and the big right triangle, which means that angle 2, 3, 8, and 9 have to be congruent. So we're going to take 70 and divide it by 2. So 2 and 3 are both going to be 35. And then we're going to take 46 divided by 2. So 8 and 9 are both going to be 23. Okay? So now, because we know that all of these are 90, we can use the fact that angles have to add up to 180, or inside a triangle have to add up to 180 in order to solve for 1, 5, 6, and 7. So 1 and 5 are going to be the same because those are identical triangles, they're congruent. They have angle, side symmetry. Or congruency, not symmetry. Well, they, I guess, are symmetrical as well. So if this is 35 and this is 90, 90 and 35 is 125. 180 minus 125 would be 55. So that's going to be 1 and 5. Because we know that those angles are 122, I believe is what we said. I forget, I really should have written that down somewhere. Yeah, 122. So we then go 122 minus 55, and that's going to be 67 right there. And we're done. See? Easy peasy. The rest of these, let me quick look through them. We can use, because we know that the diagonals bisect each other, or we know it's 90 degrees. We know that NL is 33. We know that this right here does get split in half. J to N is clearly not equal to N to L, but K to N is congruent to N to M. So we can use this the fact that this right here is 16.5 and this right here is 52, and we can figure out L to M. D to E is 15, E to H is 11, find D to F. Well, we can use 15 squared minus 11 squared to find D to H, double that, and there we go. So we know that these two are equal, so we just set those equal to each other. If this is 96 and this is 96, they add up to 192. Subtract that from 360, and then that remainder of 187, or whatever it is. It's not that, it's not right. be 168. So then we go 12x minus 9 plus 17x plus 3 equals 168. Am I rushing through these? Yes. If you have difficulty with any of them, even after I have, so here, 14, we know these two have to be complementary, so they have to add up to 90. What I was saying is the same thing here. I don't even know why they have the 46 HIF. Oh, okay, gotcha. If this is 46, this is 46. You can use X to figure out what these two are. That'll tell you what the total of I and G are, and you can go from there. If you have trouble with these, we're going to spend a little bit of time on them on Tuesday, or you can email me, and I will put up a new video. So that brings us to our last one. Oh, I need to, come in. Oh, I need to do the whole thing. There we go. Which is classifying quadrilaterals. So you guys know I already gave you the distance formula and everything that you need. So really what we're doing here is I'll just show you the basics on number one, but I really do want you guys to work through this. So if I have a graph here, I have negative 9, 14, so S is up here, 110, T is right here, U negative 3, 0, and V negative 13, 4, okay? So it says justify your answer using the distance formula. Okay, so we're not actually using slope or midpoint. What I'm going to do is I'm going to check the distance of all four of these. Okay, and that's going to tell me whether or not it is a one of these two, parallelogram or rectangle, or rhombus and square. If ST equals UV, this is V right here, and SV equals TU, then it's a parallelogram or a rectangle. If they are all equal to each other, then it's going to be a square or a rhombus. What's going to make this up is the property of the rectangle and therefore the property of the square, which is that their diagonals are equal. So after we figure out which one of these, we're also going to need to measure VT and US. If those two are equal, then it's a rectangle or a square, depending, so rectangle or square. If these two are not equal, then it would be a parallelogram. I really don't feel like writing parallelogram out, or rhombus. So if they're not, so I circled this one, I underlined this one. So we figure out whether or not, so the opposite sides are clearly going to be congruent. So we need to figure out whether all four sides are congruent. If all four sides are congruent, then it's a rhombus or a square. If all four sides are congruent and the diagonals are congruent, it's a square. If all four sides are congruent but the diagonals are not congruent, then it is a rectangle. Or sorry, a rhombus. I just misspoke. So parallelogram is going to be opposite sides are congruent, diagonals are not congruent. Rectangle is going to be opposite sides are congruent, diagonals are congruent. Rhombus is going to be all four sides are congruent, diagonals are not congruent. And square is going to be all four sides are congruent and diagonals are congruent. Have fun, everybody. I'll see you guys on Tuesday.